The cardiovascular system is divided into systemic and pulmonary parts. The systemic circulation carries blood from the heart to the tissues of the body and then returns it to the heart. Oxygen-rich blood is pumped from the left ventricle into the ascending aorta. The aorta then makes an inverted U-turn to form the aortic arch, which gives rise to branches that supply the head, neck, and upper limbs. Then, the aorta continues posterior to the heart as the descending aorta, which travels through the thoracic and abdominal pelvic cavity. It supplies the organs of these cavities and the lower limbs in the systemic capillaries. Oxygen is exchanged for carbon dioxide, resulting in oxygen per blood. The oxygen per blood enters the right atrium via the superior and inferior vena cava. In this part, the pulmonary circulation takes place. The pulmonary circulation carries blood from the heart to the lungs for gas exchange, and then returns it to the heart. Oxygen per blood is pumped from the right ventricle into the pulmonary trunk. The large pulmonary trunk divides into the right and left pulmonary arteries. These arteries transport blood to the right and left lungs in pulmonary capillaries. Carbon dioxide is exchanged for oxygen, and this results in oxygen-rich blood that then flows through the 4 pulmonary veins and enters the left atrium.
So, how do my DIY model help students in their learning process? I realize some students having problem when they try to understand this topic. Therefore, I try creating a model that is simple yet easy for students to see how it works. Thus, this 3D model would definitely help students in differentiate between systemic and pulmonary circulation system. But what is so unique about my DIY model? In this project, I've been using polystyrene as the main material to create a DIY model of systemic and pulmonary circulation system. I came across a lot of DIY models in the internet, but none of them are convenient to be used. Some of the models in the internet looks visually realistic, but in terms of material they use, they are very inconvenient and difficult to be found. Compared to my model, it is very convenient to build, does not consume much time. On top of that, my DIY model doesn't require me any cost. I can find all materials at home: recycled polystyrene, watercolor, permanent marker, a cutter, and a cardboard. Therefore, my objective to create this model is not only to help in learning process, but also to let everyone have the opportunity to try creating their own systemic and pulmonary circulation according to my idea. Have fun trying!